This video is going to focus on voltage testing. We're going to primarily look at DC voltage testing, what some of the setup is, the ranging that I might have, and where I need to put my leads. So first, let's talk about the meter that we're using. This one is an auto ranging multimeter. This one happens to be a BluePoint model made by Snap-on. I've got my off setting, and then I've got a variety of different measurement settings. We're going to focus on really just the second one here and the third one. So these first three are voltage. My first one with the sine wave is AC volts. My dashed and on-off sign represents DC. And then I've got millivolts, and that can toggle between both AC and DC. We can also look at our display up top and see that it tells me DC here, and then that switches to AC in this other mode. This meter is auto ranging, and so that means I'm going to have to pay attention to when I'm in the auto range mode that the units on this is going to change as it sees different inputs. Anytime I use a meter like this, I always want to audit whether or not it works. I want to make sure that my leads are in good condition and that I have the ability to measure whatever it is I'm going to measure on a vehicle or a system. If I don't have that confidence in my tool, it's going to be really hard to make progress and take readings and move forward in the diagnostic plan. So to do that, I want to first go to my resistance or continuity check. I want to take my leads and just do a quick visual inspection, right? Make sure that these are in good shape. These are electrical tools. They are somewhat sensitive, and so it's easy to crimp and damage a wire or damage the tool. So I'm going to start by going and plugging into my COM port, matching again my setting of ohms to my omega symbol here. And then with all that plugged in, I should be able to take my leads and touch them together. And as long as my leads are in good shape, I should see pretty close to 0 ohms. This is going to fluctuate just a little bit based on the resistance of my leads, but generally a 1/10 of an ohm like this is pretty good for an automotive grade DVOM. If I was to connect these together and I get OL, it remains here, that tells me there's a problem with my leads, potentially the leads themselves or the jacks where I plug into the DVOM, and that means I need to look at fixing this meter before I can use it for any kind of tests. Now that we've got some confidence that my meter is going to work well and that my leads have a solid connection, I'm going to go ahead and set up to do some voltage testing. And so to do that, I always use my COM port here, and then I'm going to look for the setting I'm pursuing plus the matching symbol down here at the jacks. I'm going to measure DC volts. I know this because it's labeled up here on the power supply, but I should apply this thinking anytime I go to do a measurement. Most things in a vehicle that are operating from battery power are going to be DC. So I'm going to go to DC volts right here. I get confirmation of DC at the top. I know I'm set up for DC now. I'm also going to take my leads and go ahead and place them where I'm getting power and where my ground is. This would be similar to me measuring open circuit voltage on a battery on a vehicle. So you'll notice the auto ranging took place. It went from millivolts up to volts with 2 positions, 2 whole numbers, and I'm reading 12.07 volts. So I know that this power supply currently has the ability to put out 12.07 volts. So what I'm measuring right now is just what's available at the power supply. I'm not necessarily looking at what is my bulb using. Anytime I do a voltage test, there's different ways that I can do this. This is just like measuring the open circuit voltage of a battery. It tells me that that energy and potential exists at the battery, but not necessarily what a component within the car is using. To be more accurate, I'm going to want to do a voltage drop test or get closer to the component. So let's look at the latter one first. If I move my lead and go here, now I'm going to understand that at the input of this bulb, I've got full source voltage or 12.06 volts available at that wire. Is that what the bulb is using? Maybe, but is my test showing me exactly what that bulb's using? No, not at this point. So this is an example of just open circuit voltage testing where I'm getting just an idea for what could be and what's potential. A better test is always to do a voltage drop test because it shows me the dynamic resistance and drop that the component is using. So to do that, I'm going to look at how many volts come in versus how many volts go out. So here we see that the actual drop of the bulb is less than what we saw at the source here or even at the input to the bulb. What does that mean? That means that there is drop somewhere else in my circuit that's taking away a fractional amount of that voltage. So let's talk about why this number is different and how to find where that other voltage has gone. Let's say that this is a taillight bulb. This bulb needs to have 12 volts come in, it needs to have a good ground, and it needs to be able to use the full voltage that comes from the source. If the bulb was dim, that's telling me that it's not dropping the full amount. And so here we can see I'm not dropping the full amount, so we could try to figure out where that's coming from. I would want to start by looking at, up here I think I've got 12.06 or 12.07 volts. Is all of that making it to this point? And so I would go and compare the potential from that point to this point, and then my meter is going to show me the difference of those 2 points. And so if I range it, so we can look at just volts consistently without conversion, 0.003 of a volt is being dropped in those connections. So here I'm losing 0.003 of a volt just in that connection in that wire. Let's repeat that test on the ground path. And there's 2 ways I could do this one. If I go from these 2 points, that's going to tell me just what this wire is dropping. And so here we've got 1/1000th of a volt being dropped just in that wire. But we know that the construction of this board has integrated an extra wiring connection from this lower point all the way back up here. So let's test that. So I'm going to keep at my ground path for my bulb. I'm going to take my lead and go all the way up to the ground at the top. And so now I've got almost the entire 0.02 of a volt. The balance is really all left in here. So I had a few thousandths being consumed here, and then I've got 18 thousandths being consumed at the ground. So now we see really where all the extra voltage has gone and been dropped. So we'd started with 12.07 here. We saw about 12.04 being dropped of the bulb. And so we knew that there were 2 to 3 thousandths worth of a volt being dropped somewhere else in the circuit. We saw 3 thousandths get dropped up here, and we're seeing 18 thousandths being dropped on the ground path. When I add that drop to my bulb drop, now I'm seeing the full source of potential that we measured initially. This is a great example where voltage drop testing can really help us understand what's happening with a circuit when it's in operation and when things are dynamic. We want to do these dynamic tests because most of the time our customer concern is for the system in operation. And so when we test that system, we need to test it when it's in operation to see what the fault is and make the quickest path to a repair. Let's talk more about how this meter functions and why we chose the connections that we did when we did that volt drop test. One of the challenges I have with students early on is that we get in this mindset that this red lead always looks at power and the black lead always looks at ground. And so we'll ask somebody to measure voltage on something and they say, all right, I need a good ground. They pick a chassis ground or the battery negative, and then they go about with their red lead and look for a measurement point with that. Sometimes that's the process we need to go through, but I think it leaves out the conversation of really what's happening inside this meter and what is it doing. So I talk a lot about the difference of potential. These 2 leads, when I hook them up, my meter just tells me what's the difference in potential between the red lead and the black lead. It doesn't have to be power on one side, ground on another. We see in volt drop testing, that testing is really useful, and I was looking at some power on each to find where I had a drop. I was looking at ground coming out of the bulb and ground at the power supply. I saw the difference, and that helped me understand the operation. And so I really need to think about what's the difference between these 2 points. Those are some of the tests and voltage drop testing I'm going to do with the DVOM and the importance about setup and how I use this. As a technician, I'm really going to have to use this tool and get acquainted with it so that I can build some confidence. Another key is that I need to be thinking forward and thinking about when I put my leads in place, what do I expect this reading to be? I need to have that preconceived idea, because if I have this idea that I expect to see 12 and then I get 12, there's some confirmation in my mind that I did this correctly, and that's going to build trust and build comfort with this tool. That's going to help as you go through pinpoint tests and diagnostic trees to solve problems.